Hello everyone, my name is Nannan. I'm from Beijing University of Technology. I will show you my paper. The title of my paper is Dynamic Traffic Network is the multi-mode travel mode function recommendation. I will introduce my thesis from 5 aspects: introduction, definition, model, experiment, conclusion. Let's begin. With the continuous development of urbanization and the improvement of an economic level, people's travel demands become increasingly diverse. When demand exceeds the carrying capacity of the transport system, various traffic and even environment problems will arise. The complex selection behavior of people in multimodal transportation network determining the distribution of travel demand on the transportation network. From the perspective of balance the distribution of traffic demands, personalized travel mode recommendation has great research value. This paper finds that the travel behavior of users on a multimodal transportation network is an embodiment of information network, and then proposed to apply the representation learning technology in heterogeneous information network to transportation travel, and combined with dynamic transportation network to recommend multimodal travel mode. The figure on the left illustrates the interaction between the user's spatial tempo travel trajectory and the transport network, where the user uses multiple modes of travel to continuously shift between this complex transport network, eventually forming a chain of trajectories. Definition: we construct a heterogeneous information network with the temporal attribute of a user travel mode, origin and destination, and the travel mode to optimal potential features by learning the semantic relationships between objects such as user and travel mode and its corresponding origin and destination. The concentration of a network schema which specifies the type constraints on the set of objects and the connection between them. There is a connection between user and travel modes, indicating a user and user relationships. There is a connection between locations and travel modes, indicating a good and directed relationships. It shows the 4 metapaths used in this paper, where user and time are closely linked. Then introduce the model. The figure above describes the overall framework of this function recommendation model. Heterogeneous information network as input and embedding layer preprocess the model data with contained features to generate an initial node embedding. Then in the metapath aggregation layer, the selection metapath is aggregation with its good neighbor nodes for dynamic modeling, and the semantic information between the target node and its neighbors is aggregated to optimize embedding of user and travel modes. And finally, the feature embedding of user and travel modes are first for multimodal travel mode recommendation. Define 2 metapaths. The initial feature vector of each node is known, and the feature on the left illustrates the 2 process of metapath aggregation. The process is mainly divided into 2 steps: internal aggregation of metapaths, aggregation between metapaths. Internal aggregation of metapaths. Choose a suitable aggregation function to aggregate the embeddings of second of second-order neighbor nodes to obtain the embedding of first-order neighbor nodes, and then aggregate the embedding of first-order neighbor node to obtain the embeddings of target nodes. Aggregation between metpaths. Aggregate user embeddings from different metpaths to get the final embeddings. Metpath aggregation functions. In this paper, a neural network is used to aggregate the information of target nodes and their neighbors. 3 aggregation functions are shown below. Mean aggregation function. The eigenvector of the target node's neighbors are averaged and then staged together with the target node eigenvectors, which two non-linear. The second aggregation functions, the neighboring node of the target node are randomly disordered as the input sequence, and the result vector representation and the vector representation of the target node are separately stitched together after a non-linear transformation to obtain the vector representation of the target node at the layer. The last aggregation function. Unlike the LSTM aggregate function, it doesn't have to consider time series conditions and can be used directly as an input sequence to generate new features by convolution operations. Semantic aggregation. Semantic aggregation are also divided into 2 steps. Aggregation between nodes with a simple math. They are using the metpath UVL as an example. The average aggregation function is used to aggregate the embedding of the second-order neighbors, and the aggregation result is spliced with the first-order neighbors to obtain the embedding of the first-order neighbors. The feature embedding of the target node is updated using the same average aggregation function to aggregate the first-order neighbor node embedding. In this paper's recommendation model, time plays a key role in recommendation to user a travel mode that meets their personalized needs. So when model used by dynamically, users are temporal, and the LSTM aggregation function is used here better. Aggregate the embedding of user and different metpaths, where sigma is a different metpath with the user as the target node. The dynamic mode of travel mode is similar to this. Evolution prediction. In this recommendation model, we predict the probability of a user choose a travel mode at a given time, which is in the range 0-1. The loss function in this model use a point-and-point loss function, and the model is adjusted by the loss function to produce optimal results. And this are the instance sets of positive sample and negative sample, respectively. Experience. The next part is experience setting. To evaluate the effectiveness of the dynamic traffic network multi-modal travel mode recommendation model in this paper, we conducted experiments on a dataset from the Microsoft GeoLab project. To verify the validity of our proposed methods, 3 different representative recommended methods are considered in this paper. To evaluate the recommendation performance, we use the case precision as the case recall and the case normalized discounted cumulative gain are used as evolution indicators. Result analysis. As shown in the following two tables, we can know the dynamic traffic network multimodal travel mode recommendation model shows the best recommendation performance, indicating that it is feasible to apply the user's spatial temporal travel trajectory to a heterogeneous information network, and the MatPath graph neural network is used to capture heterogeneous information, which produces a good recommendation effect. Let's look at these three results. It can be observed that the recommendation of performance of our model is significantly improved by adding more MatPaths. Also, the impact of different MatPaths on recommendation performance varies. To observe more clearly the effect of aggregation function on the performance of recommendations, this paper will illustrate it from two perspectives. Under the same conditions as the training set and the test set, the precision and recovery performance indicators are compared using different aggregation function models. We divided the data into 5 equal parts, one of which is used as a test set. The remaining data is static as a training set according to 20%, 40%, 60%, and 8%, and are compared with different aggregators. Here we can see that with the increase of training set, the training set did the improvement of recommended performance decreasingly gradually. The left shows that the recommended performance of the model has been improving over the data change from 2007 to 2020, which also improves that our model is more effective as the travel demand increasingly. The right compares the recommendation effect of our model on five different work days and drag days and rest days. It is not difficult to see that the recommendation performance of the rest days is slower and less stable than than of working days, because the recent days travel on working days is more stable, and the travel demand on rest days varies greatly. The latest part is conclusion. In this paper, our proposed multi-modal travel mode recommendation model based on dynamic traffic networks is feasible and effective. The model constructs the user's historical spatial temporal travel trajectory into a heterogeneous information network and provides insight into the user's preference for travel modes. MatPath graph neural workdays for dynamic modeling of recommended objects play a key role in the overall recommendation process. At the system, the real-world dataset is used and the dataset is cleaned, filtered, and integrated with new data structure. And experimental evolution shows that the proposed methods in this paper produce good recommendation performance when applied to the recommendation of multi-modal travel modes. However, there is still relatively little work in this area. The aspects considered are not comprehensive enough, and there is much room for improvement. There are forests. Thank you for your attention.